Good afternoon, everyone, and welcome to MOS Live Ask a Scientist. My name is Christina. I'll be serving as your moderator today. And even though you can see my face now, you'll mostly be hearing my voice in the background as I share your observations and questions with our educators today. In just a few moments, we will be meeting those educators and they'll be answering all of our questions about reptiles today. If you would like to ask a question and you happen to be watching us on MOS live on Zoom, you can share a question by clicking on the Q&A button at the bottom of your screen. If you happen to be watching on Facebook or YouTube today, unfortunately, we cannot see your questions, but we are so happy that you are joining us today, and we hope you enjoy the program. Lastly, if you are watching on Zoom today and you need captions, you can get those by selecting closed caption button at the bottom of your screen and then selecting show captions. Now, all that being said, I would like to invite our educators to turn on their cameras, introduce themselves, and share your favorite reptile with our audience today.
Hi, everybody. My name is Karen. My favorite animal, or I should say my favorite reptile that I work with here at the museum is our American alligator. It's always fun and people get super excited to see him.
Hi, everybody. My name is Matt, and my pronouns are he, him. The favorite reptile that I currently work with at the museum is a big snapping turtle that we call the Hulk because he's big and because sometimes he's a little bit green.
Hi, my name is Sue. My pronouns are she and her. And my favorite reptile right now at the Museum of Science is the Brazilian rainbow boa because it's one of the most beautiful snakes with iridescent scales in the world.
Those all sound like amazing reptiles, and maybe if our visitors come see us, they might be able to see some of these animals in the future. So we do have a couple of questions coming in, and maybe we'll start today with Harrison, age 5, who would like to know how many different types of reptiles are there?
That's a great question. And I'd actually, before we hop into that, I'd say, what is a reptile? I feel like that's always a good place to start for our Ask a Scientist with our animals. So there's a couple of characteristics that you can think of if you're looking at an animal and saying, is that a reptile? And one has to do with what's covering up its body. So you can kind of see in my picture behind me, reptiles all have scaly skin. It's one of their characteristics. They're ectothermic, cold-blooded. It simply means they don't produce their own body heat and they rely on their surroundings. They are vertebrates, much like we are. If you reach back, you can feel your lumpy bumps. That is your backbone. They breathe air, much like we do. And last but not least, reptiles have some sort of egg development. There's actually a lot of variation. We can talk more about that if someone has a question. But it is an egg development either inside of the mother or laying a nest externally. And then as to how many different species, do you know, Sue, off the top of your head? Awesome.
11,000, and the majority of those are snakes.
Sorry, how many did you say, Sue?
11,000.
11,000. Wow, that's more than I would have thought.
Species of reptiles, mostly snakes.
It's interesting that you bring up snakes, Sue, because one of our questions from Oliver, age 4, was he actually wanted to know how many different types of snakes there are. Maybe it's too much to count, but if that is too much to count, maybe you can give us some examples of them.
I can give you the species number. That's 3,500 species worldwide.
Excellent. And do you all know if we can find any snakes here at the museum?
Oh, at the museum for sure. I'd say actually just like the majority of reptiles are snakes, the majority of reptiles we have at the museum are probably snakes. They range all sorts from local snakes that you would find right here in New England, like our eastern milk snake, or even our one venomous species that we keep here, the timber rattlesnake, all the way to those real tropical ones, like Sue mentioned earlier, the Brazilian rainbow boa, to really dry desert snakes, more humid environment snakes. So we have lots and lots of snakes that live here at the museum, and probably some we don't even know about in the walls.
I won't tell anybody. For our next question, we have a different reptile that folks are interested in, and Quill would like to know, what is the difference between a crocodile and an alligator?
I can handle that. There's actually a bunch of differences. One of the more interesting ones is that some kinds of crocodiles are much better suited to living in salty water than alligators are. And they have special glands that allow them to pull salt out of their bodies before it can endanger them. However, probably most of us don't want to get a good look at either the glands of crocodilians or any of the other parts inside them. So a really easy way to tell on the outside has to do with their head. The heads of alligators tend to be fairly broad and wide, like the blade of a shovel. Crocodiles have heads that are much skinnier. They look very much like an isosceles triangle. And then finally, if you look at the teeth, all of the teeth on an alligator that you can see when their mouth is closed are pointed down. All of the teeth on the bottom jaw are hidden inside of the mouth. Whereas crocodiles have a couple of little notches on the end of their mouths, and you can see two of their bottom teeth poking up.
I always like to say that their snouts, a alligator snout looks like a letter C, and a crocodile snout looks like a letter A, because nothing in the English language works the way you want it to.
I think that's just going to confuse me, Karen.
You're welcome.
Now, for our next question, let's see. Do you all know what is the oldest living reptile right now?
By oldest, Christina, do you think the questioner means oldest is in how many years they live, or?
I'm guessing that's what I'm guessing that if I were to interpret this, I would say they want to know maybe like of reptiles that are alive today, which one has the longest lifespan?
Probably
I
fox
think
turtles,
it's
Galapagos tortoises.
probably the Galapagos giant tortoise.
At least that we know of. I mean, it's hard to know exactly how old
that we know of. There are records that go back maybe 250 or 300 years. They think they could live up to 500 years, actually.
Yeah. And that's kind of a key thing with any science. When you read these records, I think the first thing that's always good to sort of see is, what are they basing that on? What's the documentation? How do we really know? Did somebody actually see this thing get born? So yeah, those records with some of these turtles are literally records that go back to zoos or explorers that saw that particular animal when it was born.
And I do believe there's still one of Darwin's Galapagos tortoises somewhere in captivity. So we do know that that one is 250 something years old. But I definitely say the turtle group in terms of reptiles are the ones that are the longest lived, hundreds of years, including lots of species of sea turtles as well.
Excellent. That is fascinating to hear. Maybe completely switching gears, we have a question from Oliver, age 4, who's interested in reptile bowel movements. And he specifically would like to know where do turtles poop?
A great question, Oliver. I love it. So reptiles have what we call a cloaca, as do most bird species as well. So not to get too graphic, but we may poop and pee differently as a human, as a mammal. Reptiles do it all from that one hole, the cloaca. And real fun fact about snapping turtles, like Matt mentioned earlier, is in the winter, they will snuggle real down deep into the water and the mud, and they breathe through their butthole. As a 4-year-old, I'm sure you appreciate that.
That is fascinating. As an adult, I think I appreciate that, Karen. For our next question, we have from Lydia, a 4.5-year-old, who would like to know, what are the different types of rattlesnakes?
There's a lot of them. There's over 30 species of rattlesnakes. I hope we don't have to name them all. But in New England, as Karen mentioned earlier, we only have one species, which is the eastern timber rattlesnake. But for example, there's diamondback rattlesnakes. One of my favorite examples is actually one of the clues that scientists are using to infer why rattlesnakes have rattles. One of the major theories is that rattles evolved in rattlesnakes because you've typically found these snakes around large grazing animals. And one of the bits of evidence they use to support that is that there's a species of rattlesnake that lives on Catalina Island off the coast of California that doesn't have a rattle. I mean, it has all the other features of a rattlesnake. They look similar, they have the same genes, but they never evolved a rattle. And the theory is that on that island, they didn't have these large grazing animals to warn off before they got stomped on. So lots of rattlesnakes.
Cool.
And I'll add that I think we have a rattlesnake in our museum collection if folks would like to visit it in person in our live animal center. So for our next question, would you all be able to explain a little bit more about what does it mean for a reptile to be cold-blooded?
For sure. I'm happy to talk about it. So we like to use the phrase ectothermic. It's just a little more scientifically correct. When we say cold-blooded, it makes people think that the animal's blood is actually low in temperature, which is not entirely true. I mean, for us endothermic or warm-blooded mammals, as a human, our average body temperature is about 98.6 degrees Fahrenheit. Reptiles also have sort of an ideal body temperature that their body works best at, but they are not able to produce that heat from the inside. So I just ate lunch and I'm using that sandwich and I'm using my apple, and my body is currently making some of my own body heat. So using that food as fuel. Being an ectothermic animal like a reptile or an amphibian or many other groups of animals as well, they don't need to eat as often, which in some ways is advantageous. If you don't need, or if you live in an area that doesn't have a lot of food easily accessible, if you only have to eat once or twice a week or once or twice a month, even for some reptiles, that's pretty advantageous. And also it does mean that in order for their body to work on metabolizing that food, so breaking it down into energy, they often do need to gain energy from the sun. So if you've ever been walking down by a river or a pond on a good sunny day, even if it's a little chilly, like at this time of year, you might see some turtles out sunning themselves on a log or a rock. There was one time many years ago here around the Charles River, somebody found an alligator sunning itself on the shore in the month of October, and they called the authorities because we do not have alligators that live here in the Charles River. So thankfully, that particular reptile was captured safely and lived to tell another tale, because it probably wouldn't have made it through the winter months. So yeah, so it's just how they get their body heat. They don't need the food to do it. They need to use the energy surrounding them.
That's fascinating. And I think related to this question of, I guess, resting or sleeping, Leo, age 5, would like to know if crocodiles sleep.
They do, Leo. Yep. Alligators and crocodiles definitely go through like sleep rest cycles. They can close their eyes. They look very cute when they're asleep. I don't remember off the top of my head what their primary activity is. We often coarsely say that animals are either diurnal when they're mostly active during the day, that they're nocturnal and mostly active at the night, or crepuscular when they tend to be active at that sort of twilighty phase between them. I would guess that they're either crepuscular or nocturnal, because one of the neat things about crocodiles and alligators is they actually have a shiny layer in their backs of their eyes called a tapetum that can reflect light back through the retina. So it has sort of a second chance to be seen. And that's one of the reasons why crocodile and alligator eyes, kind of like cat eyes, will glow in the dark if you shine light on them. So they're probably crepuscular and nocturnal, but they can absolutely take a nap if they want to.
Excellent. And we have a couple of questions coming in about dinosaurs, which I think might be a really great opportunity for us to learn a little bit about whether reptiles and dinosaurs are related, and then connected to that, if they are or if they aren't, when have we found examples of these skeletons out in, paleontological digs, for example?
So despite the fact that like Tyrannosaurus means what, angry lizard or big lizard, dinosaurs are not reptiles. They're their entirely own separate group, extinct group of animals. And what we have today that actually is most closely related to most dinosaurs, not all, are birds. So birds are sort of like modern day dinosaurs. There was a branch of dinosaurs that eventually evolved into modern day birds. So we still think that some reptiles had a little bit of scaly skin, but we now have very solid evidence that many species of dinosaurs were covered with feathers. So you think about the real ferocious velociraptor and their dark, sort of scaly, gross looking skin. Yeah, they're actually covered with big fluffy feathers. They were probably still pretty terrifying. But yeah, so modern day birds are most closely related to dinosaurs. There were other parts of that question too, Christina.
Think our folks are interested in sort of thinking about examples of when dinosaur remains or skeletons were found. So I was trying to see if we could relate that to maybe reptile remains that were found instead.
They have common. They both have common ancestors together that date back, well beyond the Triassic. So that's 350 million years ago. So Karen.
Sure.
Yeah.
Okay.
Yeah.
A long time ago.
And I think one of the oldest fossils that a reptile, not something that was paired ancestor of reptiles and dinosaurs, was one that was about 450 million years old. It was only about 8 inches long. I can't remember the name of it, but it has all the characteristics of a modern lizard. But that's where we decided that there's actually a lizard in the fossil record, and actually the oldest discernible reptile.
And there were definitely prehistoric reptiles that lived at the same time as the dinosaurs. So often, especially when we're kids and we're reading fun story books about dinosaurs, they might have things like the mosasaur or the plesiosaur, or even the pterosaur, the flying ones. None of those animals are actually dinosaurs. They are all reptiles. So pterosaurs are flying reptiles. If you like the show Dino Train, highly recommend it. That family of pterosaurs are actually reptiles and not dinosaurs, in fact.
And it's interesting you bring up please with the mosasaur, specifically Karen, because we had a question from Quill about whether Mosasaurus was a reptile, and also how long did they live for, and how big could they get?
Those are all very specific questions. They were very large. I'm trying to think of they were definitely larger than your average school bus, based on fossil remains. The question is, were some of them as big as, say, 2 school buses? And honestly, I'd just be making a guess. I don't know if Matt or Sue have more on the tip of their brains information about mosasaurs.
Not specifically. Sue, do you have more? Okay. The one thing I'll add, though, is that they're only one example of these marine reptiles that filled the seas during the age of the dinosaurs. There were also plesiosaurs. We actually have a little fossil that we use in our outreach program of, I think it's a pliosaur, and that was a tiny one. It was only about the size of a fish. And then one little shout out I'll bring to the museum is that if you come and visit us, you can actually see a fossil, a real fossil of a creature called Nycthyosaur, which looks for all the world like a fish. I mean, in fact, it looks like a combination between a fish and a dolphin, but there are incredibly important details on the inside of its body that you can see in its fossilized bones that mean that it's much more closely related to modern reptiles than to fish.
And Matt, I think they got pretty close to the size of a blue whale.
Mosasaurs?
No, ichthyosaurs.
Oh, okay. Ours is not the size of a whale. I guess we got to run.
No.
Well, it sounds like a fun thing for our visitors to try to visit, and we'd definitely love to see them come to the Museum of Science. Thinking about some of our other questions here, Julianne would like to know, maybe moving away from the aquatic reptiles, do all reptiles have scaly feet for climbing?
Definitely not. I actually feel like most reptiles, their feet are definitely a different type of scale. And I'm thinking of a classic climbing reptile, the gecko, where there's a whole slew of different species of gecko, but they have really specialized pads on all 4 of their feet that actually can adhere to almost any surface, even the smoothest surface, the smoothest glass, the smoothest plastic. And it's actually a physics type of connection. It's not like sticky. It's not like a suction cup. It's very, very different down at the atomic level that allows them to have those amazing abilities in climbing straight up. As for the pads of other climbing reptiles, I don't know that their scales really do much on their feet. I think it's mostly claws if they're climbing reptiles. Does that sound right?
I might say something about the snakes who climb. So though feet at all, but they use some adapted scales on their belly to actually be able to climb, which is awesome. So they have big, flat, kind of tire tread-like scales, and they can lift the back edges to kind of propel themselves up the bark of trees, kind of pushing off. And it's kind of interesting that many birds that snakes prey on up in the trees, they've adapted to lay their nests, put their nests and eggs in trees that have very smooth bark, because they know that snakes are going to have trouble climbing a smooth bark tree. They need a rough bark to get those scales into and push themselves off.
That's fascinating. And those photos were definitely a nice way to visualize it. Thinking about not necessarily the features of reptiles, but their intelligence. Kyra, age 8, was wondering if you all know what is the smartest reptile, and I might just broaden that to say if you can say anything about reptile intelligence.
It's hard to calculate. I mean, I know at least when I've been training on lots of animals here at the museum, the birds and mammals have an easier capacity to recognize individual humans and sort of like or dislike them, where the reptiles are a little more, I don't really care. Like, I'm used to being picked up, but I don't know that you're Karen and you're Matt and you're Sue, that type of thing. But I will say, I was talking about the American alligator is one of my favorite animals here to work with, and they are trainable, which a lot of people don't recognize. So our current American alligator, Nash, is target trained. So he is trained after lots and lots and lots and lots of work by our live animal center staff, as well as our educators, that when you put this little stick in with a ball at the end, he knows to come towards it. He gets a treat. He's up on his surface, makes it real easy to pick him up. Also, I just learned recently that our fish in our fish exhibit are target trainable as well. So even animals that we might think of as not having sort of our classic intelligence or what we would consider intelligent, they do have these abilities to learn and grow in ways that we might not have realized even 20 or 30 years ago.
And to add to what Karen had to say, they've also started doing a lot of research into personality and have discovered even animals like snakes may have distinct personalities, which is pretty interesting. That's not something we thought about snakes or other reptiles until recently. I always like to say when we're talking about animal intelligence that for example, snakes, they're the best at being snakes as any snake can be. Humans would have a hard time being a snake. So we always compare intelligences to human intelligence. That may not be the best measure.
That is a very good point, Sue, and maybe a good philosophy in life, generally speaking. And it seems like our folks were very interested in these prehistoric animals today. Peter wanted to know specifically if megalodons were reptiles.
I think megalodons are an ancient species of shark.
Yeah, Carcharodon, megalodon. Yeah, those were Carcharodon. That means they're in the same group as modern great white sharks. But yeah, they're an ancestral shark. They were enormous. I mean, they were the size of a school bus. The jaws that they've found are big enough for people to, several people to stand inside. So yeah, there were sharks rather than reptiles. But sharks
are fish, just to be clear. Yep, sharks are fish.
And sharks are an extremely ancient lineage of fish. One of them, just like there was a divergence between the animals that sort of evolved into the reptiles we're familiar with and dinosaurs based on features inside their body, that's also happened with fish. There are groups of fish, for example, that are jawed or jawless. And one of the things about sharks that makes them sort of extraordinary is they have a skeleton made of rubbery cartilage inside their body, instead of being primarily made of hard bone like we do. So sharks are an extremely ancient lineage of fish. Just as happy that particular example is not adding to our troubles off Cape Cod right now, though.
The megalodon is long extinct, despite the conspiracy theories you may have heard.
I'm definitely not going to the Cape if megalodon is there. Thinking about animals that reptiles can sometimes be confused with, we had a clarification question, which is, are tortoises reptiles? And also, like, how could you tell the difference between a reptile and an amphibian?
Great question.
So the first question is sort of a loaded question. So I always like to talk about when I do a live presentation with tortoises is that turtles, and tortoise just being a subgroup of that, some scientists, now that we have modern technology, can look more closely at DNA evidence. If any of you have ever heard the word cladistics, so we have classic Linnaean classification. So this guy named Linnaeus back in the 1700s kind of put together this way that we group or classify our live animals here on Earth. But with modern technology, we can do a lot deeper dives. And some scientists are looking at the evolutionary tree and at DNA evidence, and they are apt to put the turtles, including tortoises, kind of into their own separate group. So right now, yes, turtles are considered reptiles. If you answered that question on your test in school, you would be entirely correct. But it's always important to know that science is constantly evolving and changing. So as we learn new things, well, we realize maybe we were wrong in the past and have to change our thoughts, change our opinions, and regroup the tortoises. The second part of the question, I've already forgotten.
Amphibians.
Amphibians.
Stu, do you want to do that, or shall I take it?
I can actually do that if you want, Matt. So reptiles are classically described as being ectothermic, covered with scales, not super permeable skin, which means it doesn't exude water or take in water or oxygen. It's a little bit more airtight. There's a number of different features as well. They both lay eggs. Of course, not all reptiles lay their eggs in the water. They do have some kind of thin shell on them, unlike most amphibian eggs, which tend to be in little jelly and are laid in watery environments. Amphibians have very permeable skin, which means it breathes through its skin, and it also absorbs water and other chemicals through its skin, which is why if you ever find a frog out in a pond, make sure you don't have sunblock or insecticide on your hands before you handle one. They also do not have scaly skin. And Matt, I don't know if you have some other things to add to that, and Karen?
Actually, I'm going to build on the scaly skin part. Here's a picture of a kind of crocodile. And the thing to really understand about the evolutionary change that happened long ago, when the common ancestors of amphibians and reptiles started to have children with little differences, is that that scaly skin allowed those ancestral animals to live places that amphibians couldn't. Amphibians are chained to water. I mean, certainly they can come out of it for a while, but if they're out too long, especially if it's dry or hot, they'll dry out. Their skin will leak too much water and they'll desiccate. And by the same token, those eggs that Sue mentioned, if they lay their eggs someplace in the sun, they're going to dry out. So amphibians are still primarily chained to the water, whereas reptiles with that scaly skin and those shelled eggs have freed themselves of it. Now, that doesn't mean that they can't go in the water, and some reptiles like crocodiles and some turtles and even some kinds of snakes spend most of their time there. But because they don't dry out as rapidly, they had allowed reptiles to live in completely new environments that no amphibian can survive in. And to this day, there are many places where you find reptiles that you simply can't find an amphibian because of that difference in their skin.
And each class has its own advantages. So Matt was sort of saying like reptiles were freed from the water, but there's a lot of amazing ecological niches that amphibians can fill that other animals can't, which is why we have such an amazing diversity of live animals that live here on the planet Earth. No matter what environment you go to, there's going to be some sort of living creature, which is just fascinating to learn more about how they live there, why they live there, and how they survive.
That was fascinating. And thank you so much for sharing so much great information about reptiles and really other kinds of animals today, too. Unfortunately, I'm looking at the time and we are out of it. So I wanted to thank our educators for joining us for this program. And you all can wave a goodbye to our friends here.
Thanks, all. Have a great day.
And I want to thank all of you for participating in our program today. We hope you enjoyed it. And I'm sorry that we weren't able to get to all of your questions. But what I can say is that if you would like to ask more questions for shows like this or participate in our other programming, you can find out more about our virtual offerings at www.mos.org/mosathome. And also, if you would like to support the museum, you can find out how to do that by visiting our website at engage.mos.org/welcome. We hope you enjoyed the program and that you have a wonderful day. We'll catch you at the next one.